Okay, 8th graders. We're going to go through lesson 4, and we're going to review some terms that are sometimes hard to understand. The term function and function rule, okay? First of all, a function is an equation that when you put in one number, you get a value, okay? You get a number value. So, like 3n, if you put in a number for n, you'll get one answer, okay? That's called a function, when you get a different answer for every input. You get a different output for every input, it's called a function. Okay? I think.
How would you get the same answer with a different input?
Sometimes you'll have data where if you put the same, if you go and look at a graph, like on this, I'll give you a demonstration. If you went to a number like 4, 4 might have the number 2 and the number 4 as a data point. Okay? So in that case, it is not a function. The graph is not a function.
Oh,
you have
yeah,
two points that are lined up on top of each other.
I remember this.
All right?
Yeah.
So for example, let's say that you took a quiz, or everybody in the 8th grade took a quiz, and some people studied if we polled all the people that studied for 4 minutes for the quiz, do you think they would all get the same answer?
No.
No. But some people would get the same answer, get the same number correct. So that is an example of something that's not a function. If you studied for 4 minutes and you got a score of 2, or if you studied for 4 minutes and you got a score of 4. Okay? Those are not a direct correlation for how much you study versus what score you get. So that's an example of something that's not a function. Okay? Examples of things that are functions are things like this, where you're converting yards to feet. Since there's 3 feet in a yard, then for every yard you input, you get a different number of feet. Right?
Yeah.
So 1 yard is 3 feet, 2 yards is 6 feet, 3 yards is 9 feet, 4 yards is 12 feet, 5 yards is 15 feet. That's an example of a function because the number of feet changes every time you input a different number of yards. Okay? Now, what we call that then is a function rule. It's a rule for the number of feet to yards, or the number of yards to feet. There's a function rule that you can write for that. Okay? Now, functions are often written in tables. Okay? So, let's say that somebody gets paid to play a game, $139.50. Oh no, they buy a game. This is a function rule for a game.
Expensive game.
Yeah,
Just
What's
came
the
out.
game?
I don't know.
The world's largest game of Jenga?
There must be some kind of game that's expensive. Maybe,
A new game.
Expensive game.
Console games are $60 when they come out.
okay.
So
How about like a PlayStation portable, PS, whatever you call it.
Those are
But,
like $60. So.
$60. Even the brand new ones?
Oh wait,
The
wait.
PS Vita is around like 200.
Bundles.
Okay, so then
Game bundles.
game
Those-
bundles.
I need to
Those
look
would
it
get
up.
a lot.
Alright, so let's say you get a game bundle. And it's $139. You can choose you can choose different game bundles. Alright? So, one game would cost you $139.50 plus $10 shipping. And so for every game that you purchase, you have to multiply the number of games by $139.50 and then add $10 in shipping, right? This would be a function rule for that. It is written this way with this squiggly F. So it's the function of the cost of games, function of the cost for your order is $139.50 per game, so $139.50 times the number of games you order, plus $10 in shipping. And that's how you write that rule. All right, so that's what you're going to be doing, is looking at situations like this and then figuring out what's a rule that we can write that would demonstrate this. Okay? Now, there's some other terms that you need when you're figuring this out. One of them is called the independent variable. Oops, that's not what I wanted to do. I wanted to highlight it. There we go. The independent variable. This is the variable that is the number that is not dependent on the other number. It's the number of games that you order, for example. You can order any amount of games you want, right? It's the independent variable. Now, the cost of those games is dependent upon what? How many you buy. Right, the number of games. That's called the dependent variable because it's dependent on the number of games you buy. Now, when you're graphing, you put those on a specific spot on the graph. You always put the independent variable on the x-axis because that's the input number. This is the input number. And then the total cost, what it gives you, is the dependent variable, and that goes on the y-axis. So that's why I labeled this one dependent variable, independent variable. Okay? Then, over here, you can also, remember we talked about a chart. A chart shows the independent variables and the dependent variables. And sometimes they're called the domain of the function. The domain are the x values. And the range of the function. Those are the possible y values, or the output. So when you put in an input, you get an output. All right? And if you're listing all of the x values, that's called the domain of the function. If you're listing the y values, that's called the range of the function. Okay? So, for example, let's look at number 1. Number 1 gives us a chart. And on this lesson, this is page 29. And in the chart, we have cans of soup. And we have number of servings. So we're trying to feed a certain number of people. Trying to figure out how many cans of soup to get. Which is the independent variable? The left side or the right side?
No left.
The cans, right? This is the input. Right? What else? What's another term for this? Is this the domain or the range?
Domain.
This is also the domain. Then it gives us some numbers. 1, 2, 3, 4. And 4, 8, 12, 16. Right? So if it said, list the domain of this function, what would you write? The domain, and then you put these brackets. What is the domain? You would list all these values.
C equals.
No, you would write 1, 2, 3, 4. Okay? Now, is there a, could we keep going?
Yeah.
So the domain, we could describe the domain as being any, what?
Number.
Any number?
Any reasonable number.
Yeah, what is a reasonable domain for cans of soup?
5.
No, any, what? Any integer? Any irrational number, any whole number, right? Can't be an integer, we can't have negative cans of soup. Right? So any whole number we would write as a reasonable domain. Okay? Any whole number. Alright?
I have a whole number.
Again, a reasonable range. These are the range values, right? So we would list them as 4, 8, 12, 16. Or we could describe the range as, again, what?
A reasonable number.
Okay. Would it have to be whole numbers for servings? Probably not. So any rational number, yep. Except probably not negative numbers.
Obviously.
So any positive rational number, right? Now, let's write a function rule. So what we have to have is we have to have variables. What are our variables?
Letters actually.
Yep, so we have to define those.
C equals number of soups.
Number of soups.
Soup cans.
C is cans.
Soups.
Number of cans.
And
Hashtag.
what else do we need?
S.
S for
Okay,
serving.
S equals servings.
How many soups can I eat?
Now, let's write our function rule. Oh, yay. We'll come back to that later.